Today's lesson is Chapter 12, Lesson 11, on pages 967 through 971. Our objective is I can calculate the volume of composite figures. Vocabulary: composite figures. Question 1. To find the volume of a composite figure, you need to blank the prisms. Question 2. In the video, you notice that there is a number blank listed after the unit, which means that the number is cubed.
You will recognize that volume is additive by finding the volume of a three-dimensional figure composed of two rectangular prisms. First, let's review some important ideas. We can define volume as the number of cubic units needed to fill the space inside a three-dimensional figure. We find the volume of a rectangular prism by multiplying its length times its width times its height. You might encounter three-dimensional figures that are a little more complicated. If you analyze this three-dimensional figure, which looks sort of like an L, you can see that it is not your ordinary rectangular prism. So, to find its volume, what we need to do is we need to chop it up into pieces. The key to success is chopping the funny-looking three-dimensional figure into figures where you can just use a formula to find the volume. For example, I could cut this figure vertically. I could slice it down like this. And what I would have is a long rectangular prism, which I've shaded green, and a smaller rectangular prism, which I've shaded blue. There are other ways that I could cut my prism, however. What I just showed you involved a vertical cut. We can also cut this figure horizontally or across. And the result then is a smaller rectangular prism on top and a longer rectangular prism on the bottom. I've shaded them green and blue to help you see the difference. I'm going to use this method of chopping up my three-dimensional figure, but either one would work equally well. To find the volume of this odd-looking composite three-dimensional figure, I'm going to find the volume of the small green rectangular prism and also of the blue rectangular prism. Fortunately, I have formulas for finding the volume of a rectangular prism. I'm going to next write in my formulas. I'm going to take the length times the width times the height to find the volume of the first rectangular prism, and then I will do the same to find the volume of the second rectangular prism. In my next step of solving this problem, I need to substitute in the actual values, the length, the width, and the height. And this is probably the trickiest step, because we need to determine the side lengths of our rectangular prisms. Let's analyze first this green rectangular prism. I can pretty easily see that the top side length will be 2 inches, and I'm going to label that right there. As for this side, that will be slightly more complicated to determine. This 4 inches right here represents the entire length up and down. To determine this length, I need to notice that this little piece right here is also 2 inches, which means that this segment right there would be 2 inches as well. 2 inches plus 2 inches is 4 inches, so I know that the side of this figure is 2 inches also. Next, I need to figure out this length. And I see right here that the general sort of height of this figure is 2 inches. So I can conclude that this is 2 inches also. And it turns out that my green three-dimensional figure is actually a cube. Had I known that the green figure was a cube, I would have written the side length cubed rather than length times width times height, but I'm going to continue anyhow, and I will simply substitute in 2 inches for both the length and the width and the height. Next, I need to determine the length, the width, and the height of this blue figure. And I see right here that the longest side is 4 inches. I see that this little height is 2 inches, and I can also identify that the other side length is 2 inches. So now I'm ready to substitute in 2 and 4 and 2 for my length and my width and my height. I've done all the hard stuff now, and I simply need to do some computation to get to my answer. 2 times 2 times 2 is 8, and 2 times 4 times 2 is 16. When I add those together, I learn that the volume of the entire figure is 24 cubic inches. Let's do a quick review of the steps you just went through. First, we cut our composite figure into rectangular prisms. Next, we wrote down the formula that would help us find the volume of those rectangular prisms. After that, we substituted in the numeric values, the side lengths that represent the length and the width and the height, and finally we did some simple arithmetic to lead us to the final answer of 24 cubic inches. In this video,
All right, let's take a look in your book. I am on page 967. So remember, a composite figure is made up of 2 or more 3D figures. So you guys have seen figures like this on Evaluate. So here's an example, and this is the Arc de Triomphe in Paris, and it's roughly this shape. So you have to find the volume of this shape, but you can't just find it so easily as we've been finding regular 3D shapes. With a composite figure, you kind of have to break it apart. So we have to separate it into 3 rectangular prisms so that we can find the volume of each and add them up. So I would separate a rectangle here. I would take this rectangle here. Actually, we're going to do it like this. We'll split it like that, and then we'll have these 2 rectangles and this one on top. So if you look down here, now we've split them up and we can kind of find the volume that way. So for this bottom part, we know that the length would be 17 yards. The width is still going to be 24 because this 24 here shows us that this width is 24, so it's going to be equal over here. And then our height is going to be 32 because remember we split it right here. So our height is going to be 32 yards. So same thing with the other side of this rectangular prism. So and it would more split like that. So this one is going to have the same height, length, and width because they are equal rectangular prisms. And then we can just multiply that as we usually do. Then we'll have the top figure, which would have 50 yards being its length, 22 being its height. This one already gives it to you. Sometimes you'll have to split it up on your own. They might give you a total and you'll have to break it apart by knowing the opposite side. And then the height, or the width here, sorry, is also going to be 24 because it still has the same width as the bottom part of this. So then when we calculate those, we get the volume for each of these, and then we just have to add them up. So we add them all up and we get 52,512 yards cubed. Remember this 3 up here means we're taking yards 3 times to the 3rd power because we multiplied volume, we multiplied length times width times height. We multiplied 3 things, so yards cubed. All right, look back at these 2 questions and answer them in the form, please.